All right, we are going to talk about climate cycles and recent climate change. So past climate data. So how do we know that actually the climate is changing? Well, scientists are able to look at these changes throughout history using evidence that they gather from things called ice cores. That would be ice drilled out of glaciers. So glaciers have been around forever. So all those big, huge hunks of ice you see in the North and South Pole are called glaciers. And we can drill down into them and get nice long basically tubes of ice that tell us what the atmosphere was like at any given time in the past, because those glaciers are constantly layering and layering and layering every single year, so we can see the pattern in those ice cores. From fossilized pollen, so we can determine when the pollen was around, and then that pollen picks up information from the atmosphere around it, and when it fossilizes we can get that information from the fossil. From ocean sediments, so basically we can figure out the ocean absorbs whatever is in the atmosphere, and the sediments therefore, so all the rocks and sand and stuff at the bottom, they absorb the information or the all the atoms and stuff from the atmosphere as well. And so when those sediments or sand turn into rocks, which they inevitably do, though the information from that time is stored in that rock. And then growth rings of trees. So we can look at the climate or the weather of specific time periods, specific years, based on how close or far together rings are. And we're going to practice that. We're actually going to do an activity on Monday about that. So, all right, long-term climate cycles. So the climate on Earth does cycle. So it definitely goes through ice ages and it goes through interglacials, or periods that are pretty warm. So we're in an interglacial right now. Ice ages are long cold periods. They usually last for hundreds to millions of years, and basically most of the Earth is covered in glaciers during ice ages. And you can kind of look at that here on this graph. Oops, excuse me. Where up here, this is the amount of ice, so this would be during an ice age, and down here would be not a lot of ice, so this would be during an interglacial. So ice age, interglacial, ice age, interglacial, ice age, interglacial. So notice how they do cycle. They go up and down, up and down, up and down. Short-term climate cycles. So outside of the long-term ones where we go between interglacials and ice ages, we cycle every single year. We have seasons, right? We have short periods of climate change because of the amount of solar intensity that an area is receiving. We talked about this when we talked about the reasons for the seasons. So you have high intensity light coming in, that means it's summer, right? If we have low intensity light, that means it's winter. And because of that, we get different seasons, and different times of year have different seasons, so that's your local climate cycle. El Nino is something that impacts climate. It only happens every 3 to 8 years. We know that it's happening this year, so be watching for that. Basically what happens is those trade winds, remember the trade winds are the ones that are right around the equator, they weaken. So what happens is that the normal patterns kind of get reversed, and all of a sudden we get different high and low pressure systems than what normally happens in the Pacific Ocean, which definitely impacts our weather. And then we have monsoons, which I talked about a little bit during our last lecture, and that's the wind circulation pattern that changes directions with the seasons. Remember, when there's high intensity light, the rains end up over the land because land heats up more than the ocean. And then during the winter season with low intensity, the rain moves out into the ocean. So I hope that makes sense. Recent climate change. So average temperatures on Earth have been increasing for the past 100 years. Now nobody's debating this. Everyone understands that this is happening. This is true. This is data. We see that over the last 100 years, Earth's temperature is increasing. And this is referred to as global warming. So if you look right here, in 1900 we were below the average temperature on Earth. And as this 100 years have gone, it is increasing very quickly. Up to 2000 is when this shows too, so there's 15 more years of increasing after that. So the cause of global warming, why is it happening? We talked a little bit about greenhouse gases. These are gases in the atmosphere that absorbs Earth's ongoing infrared radiation. So you know the sun shines. We talked about radiation, how radiation gets down into Earth, and then it's going to be absorbed by the Earth's surface, especially if it's land. So it can be absorbed, reflected, absorbed or reflected, and most of the sun's energy is absorbed, especially when there is this ozone layer. Remember, that's located in the stratosphere of the atmosphere. The ozone layer is wrapped around the Earth, and as the sun is beating down, radiating down to Earth, it reflects back off, and then the ozone basically pushes it back down to the ground, keeping the surface of the Earth nice and warm. Now, the more ozone we have, or the more greenhouse gases we have, the more carbon dioxide we have, the greater the greenhouse effect. So essentially, the more carbon dioxide we have, the thicker the blanket around the Earth. And so you will get more heat being held in, and thus a higher Earth temperature. So human impact, and this is what we talked about was the debate. Some scientists think humans have impacted climate change through burning fossil fuels because that increases the amount of carbon dioxide that's released. Some believe it's through deforestation. This is the large-scale cutting down and burning of forests. This also increases carbon dioxide, and the reason why is because plants absorb carbon dioxide and release oxygen. And when you cut down a bunch of plants, they no longer can absorb that carbon dioxide and release it as oxygen. Now, essentially, that carbon dioxide just stays out there. And then aerosols. This is that like hairspray and stuff like that that you have to shake, and you kind of hear it shake, and then you spray it. There's something called chlorofluorocarbons in those aerosols, and those are damaging the ozone layer, basically tearing those 3 oxygen molecules apart. And that prevents the sun's energy from reaching the Earth when that happens. So the other side to this is that some scientists think humans have nothing to do with global warming at all. They say it's a part of a normal long-term heating and cooling cycle. So we just talked about those heating and cooling cycles. So they're saying that basically we're heading into a more steady interglacial period, which will eventually be followed by an ice age again. So this is just a normal part of the Earth's cycles, if you will, climate cycles. And you heard a little bit about that when you watched The Great Global Warming Swindle, and you will hear a little bit more about the other side when we watch The Inconvenient Truth. All right, and that is all for climate change and recent climate cycles. Thank you.